this is the homework video guide on estimating sine theta and cos theta using the unit circle. And for question number 1, we're given a unit circle diagram similar to one that we saw in our class notes, and we need to estimate sine 30 degrees and cos 30 degrees. Now from the class notes, it was determined that cos would be your x-coordinate and y would be your sine coordinate. Okay, so let's go ahead and find the 30 degrees here, right? So on my unit circle, here's 30 degrees in the red dot right there. And we want to draw a radius from the center of the circle to the 30 degrees, just like that. And we want to figure out what that coordinate is. Okay, so let me just erase this cos 30 degrees. Let me kind of write cos 30 degrees over here, just to give me a little bit extra space. Okay, so if I need to find this particular point here, I need to find the x value and I need to find the y value. Well, the y value is not too bad. It turns out that the y value is about 0.5, right? So I'm going to put a comma here and say the y value is 0.5. Now the x value is down here roughly, so what we're going to do is we're going to just redraw another x value just straight down. And if I try my best to count this up, this is 0.5, this is 0.6, 0.7, 0.8, and maybe this is a 0.85 perhaps. So that's an estimate. So the x value here is 0.85. Okay, and we also said that the x coordinate was cos theta and the y value was sine theta, right? So sine 30 degrees is roughly 0.5 and cosine of 30 degrees is going to be 0.85. Okay, so that's an approximation of sine 30 degrees and cos 30 degrees using the unit circle. Now, I just want to point out, if you went to a calculator and inputted these values in, the real value of cos 30 degrees, the real value is about 0.866. So as we can see, the approximation is very close. And what you can do is, if you have your calculator, this is what you would input into your calculator, and you want to make sure you're on degree mode. And there it is, sine 30 and cos 30. So sine 30, we get 0.5 right there, and we get 0.866 to 3 decimal places for cos 30 degrees. All right, so our answers are very close to the real answer. Okay, so that's it for question number 1. We're just using the unit circle to estimate those values. And for question 1b is just a follow-up. I want to use a calculator and I want to find the value of x using the Pythagorean theorem, and I need to round to 2 decimal places, and here's my Pythagorean theorem here. Okay, so this is just kind of verify our results here. So we know on a unit circle the radius was 1, the y value is 0.5, and I need to find the x value here. Okay, so using my Pythagorean theorem here, this is your a, this is your b, and this is your c, right? Your hypotenuse is always the c value. Okay, so if I go ahead and use the Pythagorean theorem here, this would be x bracket squared plus b, which is 0.5 squared equals to 1 squared. Okay, so now we've got to work with this calculation here. Well, x to the power 2 is going to be x squared plus. Now 0.5, if you want, you can write that as 1/2 squared, and 1 to the power of 2 is going to be 1. So 1 times 1 is 1. So now I have x squared plus. Now this is really 1/2 times 1/2, right? So 1/2 times 1/2 is really going to be 1/4. So 1 over 2 to the power 2 is going to be 1 over 4. And this is going to equal to 1. Okay, and then we subtract 1 over 4 on both sides, so we get 1 and then minus the 1 over the 4. And 1 minus 1/4 is going to be 3/4. And if you square root both sides, you get that. And then with your calculator, you want to put the square root of 3 over 4 into your calculator, and you will get roughly to 3 decimal places 0.866. Okay, so question number 1b is really just to verify your results using the Pythagorean theorem. So if I go back to my diagram here, and if I go back and just erase all this, this x value was 0.866, your y value is 0.5, and my radius is 1. All right, so going back to the unit circle now, if I just had to erase all this, I think that kind of verifies our results here. So this triangle distance here was 0.866. And it turns out that our height here was 0.5, and our radius of our unit circle was indeed 1. Okay, so all we're really doing is we're just applying the Pythagorean theorem to the unit circle to verify our results, and we do get 0.866 there. Okay, so this homework assignment is all about, it's basically an introduction to trigonometry, and trigonometry at the Math 10 level is all about solving right-angled triangles. Okay, let's do a similar question, question number 2 here. So use Let's move on to question number 2, and for question number 2, we need to use the unit circle diagram again, and this time we need to estimate sine 40 degrees and cos 40 degrees. Okay, so for this particular question, we need to kind of approximate where cos 40 degrees might be. So it might be maybe around here, maybe. Okay, so if I just draw a line from here to here, what we're trying to say that this angle right here is about 40 degrees approximately. And our goal now is to find the corresponding x value and the corresponding y value. So maybe the y value is around there maybe. Okay, so I know this isn't perfect, but this is once again, this is just going to be an estimate here. Okay, so in order to find the x value, we know that, let me grab a green marker here. We know right here this is a half, right? So we know this is a 0.5 right there. So this will be a 0.6, 0.7, and maybe this is going to be a 0.75 for the x-coordinate. And for the y value, I know this is 0.5, so this will be a 0.6, so this might be a 0.61 maybe. So if I had to estimate this coordinate here, I'm going to say it's going to be 0.75, comma, 0.61. Okay, so those right there, 0.61 is that coordinate right there. So that's an estimate, right? So we know that this is your x value, this is your y value. We know cos is x and y is sine. So that means sine 40 degrees is roughly 0.61 and cos 40 degrees is roughly 0.75. Now these are estimates, right? So if you want to find the exact answers, you would go to a calculator, and this is what I have on the calculator here. So sine 40 is 0.6427, and cos 40 is 0.766. So my answers were a bit off, but you know, this is also a very close estimate, right, to the real answers there. So there you go. That's how you do question 2A, and let's move on to question 2B now. And for question 2B, let's see if we can see what's happening here. So we need to use a calculator again, and we need to find the value of y using the Pythagorean theorem. And I need to round to 2 decimal places here. 2 or 3 decimal places is totally fine. Okay, so I know the unit circle has a hypotenuse of 1 or a radius of 1, and the x value, let's just say this is 0.766. So that's really coming from, you know, this rounded answer, 0.766. So my estimated answer was 0.75, but the real answer was 0.766. Okay, let's go back to here now. So let's label this as A, this is your B, and this is your C, right? So if I had to go ahead and input this into the Pythagorean theorem here, this would be bracket 0.766 squared plus b, which is technically the y, right? So I'll say y to the power 2 equals to 1 squared. Okay, so now we're solving for the y variable. If I go to my calculator now and input this into your calculator, you should get 0.587 plus y squared equals to 1. So 1 squared is just 1. And then y squared would equal to 1 minus the 0.587. Notice once again, you want to keep your equal sign vertically lined up. Then I have the y squared equals to 1 minus 0.587. Just go to your calculator and you get 0.41325. And then finally, just take the square root of both sides on your calculator. And we have y would equal to 0.6428. All right, so with the Pythagorean theorem, we got 0.6428, and that definitely matches, you know, that particular answer there. So if I had to go back to my unit circle here, what we're just really saying here is, let me erase this here. If I drew the triangle, what we're just trying to say here is that this x value has a distance of 0.766, and the corresponding y height was 0.6428. Right, so it's very, I would say like this answer is kind of similar to that. It's very similar, right? We're just estimating here, and if we want the exact answers, we would have to go to a calculator to get the correct answers to 2 or 3 decimal places. Okay, so a lot of estimating for this homework assignment, and once we get into the future spiral questions, we'll be able to get the exact answers here. Okay, so for question number 3, using the unit circle diagram below, let's estimate the following. So we have sine 0 degrees and cos 0 degrees. Okay, well here's 0 degrees right here, right? The purple dot, this is 0 degrees. So if I just draw like a radius from the center connecting to 0, I mean, I guess this particular coordinate here is really 1, 0, right? So this is your x value and this is your y value, right? So we know that sine is going to be your y coordinate and cos is going to be your x coordinate. So that means sine of 0 is going to be 0, and cos of 0 is going to be 1. All right, so that 1 is really the x value right there. Okay. Next one, let's look at cos of 15 degrees. Okay, so I think 15 degrees is probably, 15 degrees is a bit tough. Let's say it's about, maybe about there. Okay, so what we're trying to say is this is about 15 degrees. Okay, so since we're looking for cos is the x value, right? So what's the x value right here? So we know this is 0.5, 0.6, 0.7, 0.8, 0.9, and this will be 0. I don't know, maybe 0.95. So maybe this would be 0.95 for our estimation right there. Okay, great. And now we need to find sine of 80 degrees. Okay, well, this is 90 and this is 60, so maybe 80 degrees is somewhere here. So for sine 80 degrees, maybe it's around there. This could be 80 degrees. So now I need to draw, yeah, that right there, triangle there. So this is about 80 degrees. And what's that height right there? I mean, if I go straight across, this height is, I don't know, 0.6789. Maybe another 0.95 again. Maybe 0.95. It's pretty high there, right? So there you go. I just want to say that if I did go to my calculator, the real answer is going to be 0.97 for cos 15 degrees, and the real answer here is going to be 0.98. So I would say that my approximations is 0.95 and 95, very close to the real answers here. And all you have to do is just confirm your answers on a calculator here. And there you go. Cos of 15 is 0.965, sine 80 is 0.984, and cos of 0 is 1, and sine of 0 is 0. So our estimates are very close to the real answer. Okay, one final estimation here for this homework video, guys. So for question number 4, now we need to go backwards here. So we need to use the unit circle diagram to estimate the angle that would satisfy each problem. So we know cos theta is 0.6. Okay, so what angle would give us 0.6? Well, you need to find 0.6 on the x-axis. So we know this is 0.5. So this would be roughly 0.6 right here, right? And what we do is we just, from 0.6, we go straight up to about there. And then we just estimate this angle here. So the angle has got to be between 60 and 45 here. So it's somewhere in the middle. Maybe, I think it's maybe 52 degrees. I don't know. So we'll say that theta is roughly 52 degrees. Okay, so that's my estimate. If I went to a calculator, I know the real answer is going to be roughly, the real answer on a calculator is about 53.13 degrees, but here's my estimate, which is very close to the real answer. And moving on here for part B, now we need to find the angle, sine of which angle gives me 0.7. So we know that sine deals with y, right? So we know this is 0.5 right here. This is 0.6. This is 0.7. And what we want to do is we want to go straight across to this coordinate there, and we got to find what that angle is going to be. So if I just draw an angle slightly underneath, maybe it's, I don't know, 44 degrees, 45 degrees approximately. So my approximation, maybe it could be 44 or 45 degrees as an approximate. I know the real answer is going to be 44.43 degrees, but I guess, you know, if you're on that 45-degree angle, you're close enough, I guess. So there's my approximation there, but the real answer is that. And I'll show you the screenshot on what you would input into your calculator to verify these answers here in a bit. Let's just keep on going here. Now I have cos theta equals 0.15. So we know cos represents the x-coordinates, and we want 0.15. So we know this is going to be at 0.1. So I guess halfway here is going to be 0.5. So let's just go straight up here. Very high. So the angle that's created is actually very big, right? So it's a very steep angle. I'm going to say this angle is roughly, 82 degrees. So maybe my estimate is roughly 82 degrees. I know the real answer is roughly 81.37 degrees. But, you know, if you're in the 80s, high 80s, I guess you low to mid 80s, I guess you have a pretty good estimate of that particular question there. Okay, last one here. Sine theta equals to 0.2, so this is 0.1, here's 0.2. Remember, sine theta is your y-coordinate, right? So 0.2 is right there on the y's. So you go straight across, it's roughly around here, and then you want to just draw a triangle, and you want to approximate that angle there. So maybe that's, it's a very small angle. It looks maybe, 10 degrees maybe. 10 degrees. So theta, my estimate is roughly maybe 10 degrees, and I know the real answer on a calculator would be 11.53 degrees. Okay, so if you went to a calculator, this is what you would this is exactly how you would input all those problems that we just did into a calculator. Make sure you're in degree mode, and you would have to activate the inverse option here to go backwards, and you get answers here that are these are the real answers, and I think our estimations were very close to the real answers. So this homework assignment is all about estimating and making sure that you can follow some basic concepts of the unit circle, such as sine theta is your x-coordinate, and cos theta is your x-coordinate, and sine theta is your y-coordinate, and a lot of this is just estimating off of that unit circle.